This video is for Calc 3, section 15.4, and number 32 in our homework from the book. So it asks us to use polar coordinates to evaluate this iterated integral. So whenever I'm confronted with an iterated integral, I always write out what the region that I'm integrating over is. So that region is equal to the x's and y's such that, and then x lies between 0 and 2, and I'm getting that from dx is the outside part from 0 to 2, and then y is the part that runs from 0 to 2x minus x squared, take the square root. And once again, I'm getting that from this dy corresponds to this part from 0 to 2x minus x squared, take the square root. So then, on an xy plane, I'm going to need to make a sketch. So this would be y equals 2x minus x squared, take the square root. But I recognize that as a circle, so y squared plus x squared equals 2x. So that is a circle, and that circle would look something like this. And if I plug in x is equal to 0, I would get 0. And if I plug in x is equal to 2, I would also get 0. So let me do that. If I have y squared is equal to 0, if x is equal to 0, and y squared is equal to 0 if x is equal to 2. And so from that, I know then that this is x is equal to 0, and this is x is equal to 2. So I have a circle with radius 1, and the center of that circle would be 1, 0. And then this is a circle, and right now we're just graphing the top half of it in the first coordinate when we have x and y. By the way, I could take this and put it in a graphing calculator, and that would give me that picture. And then I would ask the calculator what is x equal to, or what is y equal to when x is equal to 0, and it would tell me this. And what is y equal to when x is equal to 2, and it would tell me that. So I could, all what I've done here, I could get from plugging this part into a graphing calculator, and I would get the same thing. Okay, so we're converting this to polar coordinates. So with polar coordinates, what we have to remember is r squared is equal to x squared plus y squared. And we have to remember that x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. And so I'm going to plug in these two equations into these bounds, and I'm actually going to do it into this version just because it makes the algebra a little simpler, I think. So let's do that. So y squared plus x squared equals 2x. So I get r squared times sine squared of theta plus r squared times cosine squared of theta is equal to 2 times r times the cosine of theta. And I'm going to factor out an r squared, and I'm left with sine squared of theta plus cosine squared of theta is equal to 2 times r times cosine of theta. And of course, this part is equal to 1. So I have r squared is equal to 2 times r times the cosine of theta. And I can deal with this equation a couple different ways, but the way I'm going to deal with it is r squared minus 2r times the cosine of theta is equal to 0. So I subtracted the right-hand side over. And then I factor out an r, and I'm left with r minus 2 times the cosine of theta is equal to 0. And so r equals 0, or r minus 2 times the cosine of theta equals 0. And of course that means that r is equal to 2 times the cosine of theta. So my r then runs from 0 to 2 times the cosine of theta. All right, so then now let's draw another graph. And so this is what we're talking about. And now this is theta, and this is r. So this would be r equals 2 times the cosine of theta. That would be that. So then the question is, what are my theta values at those two places? So what we're asking is, when does r equal 0, question mark. Well, one of them is 0, right? We know that one from up here. But the other one is then r equals 2 cosine of theta. When does that equal 0? Well, 2 times cosine of theta would be cosine of theta equals 0, dividing both sides by 2. So that happens when theta is equal to 0, pi over 2, and those are the only ones we need. There are infinitely many more places, but those are the only two I need because I'm only talking about this part, right? I'm only talking about the first quadrant. So this one is 0, this one is pi over 2. And we already had the 1 anyways. We already had the r 0 there. So this then is 0. So I input theta equals 0, and I get out 0. And here I input theta is equal to pi over 2, and I get out 0. Okay. So on my theta r plane, and if I drew the other part, r runs from 0 to 2 times cosine of theta. So from 0 to 2 times cosine of theta, and my theta runs between 0 and pi over 2. All right, so I'm going to just rewrite all that out. So I have my polar region is equal to the thetas and r's. By the way, some people might write it the other way around, might write it r's and thetas. I just happen to draw it this way with the thetas and r's. And such that theta is between 0 and pi over 2, and r is in between 0 and 2 times cosine of theta. So we're all set. The only thing left that we have to do is convert this part of the equation. And so remember, when we convert to polar, we have a function of r and theta, or a function of theta and r, depending on how you write it. And then we multiply that, so the double integral a function of r and theta times r times dr d theta. And so this part on the end is the standard part that we recopy every time. So then we just have to figure out what this part is. So we started with a function of x and y, which was equal to 2 times x squared plus y squared, take the square root, and I'm going to convert that into a function of r and theta, and so that then is equal to 2 times the square root of r squared, because x squared plus y squared is the same as r squared, so then this is the same as 2 times r. Alright, so now we're all done. So I take the integral, double integral of 2 times r, and then times r times dr d theta. So this part is right here, and this standard substitution is this part, and my r runs between 0 and 2 cosine of theta, and my theta runs between 0 and pi over 2. So now it's just a matter of evaluating the integral. So this is the double integral, 0 to pi over 2, 0 to 2 cosine of theta, and then 2 times r squared dr d theta. And r squared, we know the antiderivative of that, so from 0 to pi over 2, and 2 times r cubed divided by 3, and then evaluate that from 0 to 2 times cosine of theta, and then d theta. And so this is equal to the integral from 0 to pi over 2, and this would be 2/3, and then 2 to the third times cosine to the third of theta, and then minus 2/3 times 0 to the third. So that whole thing, and then d theta. So this is equal to 2 to the third is 8, and 8 times 2 is 16, so this would be 16 over 3. And then the integral from 0 to pi over 2, and then cosine cubed of theta d theta. And that is a Calc 2 integral that I will let you solve